This is Euclid Book 10, proposition number 55. Let's get into this, shall we? If an area be contained by a rational straight line and the second binomial, the side of the area is the irrational straight line, which is called the first bimedial. For let the area ABCD, well, this plus this plus this plus this is the area ABCD. Be contained by the rational straight line AB and the second binomial AD. So, we have the rational straight line AB right here, and we have the second binomial AD right here. I say that the side of the area AC is a first bimedial straight line. This is going to be a first bimedial straight line. For since AD is the second binomial straight line, okay, let it be divided into its terms at E, so that AE is the greater term. This is going to be the bigger term right here. Therefore, AE and ED are rational straight lines commensurable in square only. These two lines right here, AE and ED, are rational straight lines, and they're only commensurable in square. Okay? The square on AE is greater than the square on ED by the square on a straight line commensurable with AE. This is bigger than this by this amount. Okay? Because we took AB here and we turned it into a square. Okay? So this is greater than this by this. So if we added these two areas together, we'd get that. And the lesser term ED, which is this right here, is commensurable in length with AB. This is commensurable with this. And that's by Euclid Book 10, definition number 2. It may be, yeah, it's definition number 2. 10.2. It's Euclid Book 10, definition number 2, 2. Okay. And that's because of that second set of definitions. Let ED be bisected at F. ED is being bisected at F. And let there be applied to AE. So we're going to apply to AE the rectangle AG and GE. Okay. AG is two sides of this rectangle, GE is the other two sides. Now, it's going to be equal to the square on EF. We're going to take this EF right here, we're going to turn it into a square. So, the area inside of here is going to be the same as the area inside of here. And it's going to be deficient by a square figure. Therefore, AG is commensurable in length with GE. Okay. AG is commensurable in length with GE. This is by Euclid Book 10, proposition number 17. Through GE and F, okay, we're going to draw all these parallel lines. They're going to be parallel to AB. And they're also going to be parallel to CD because AB and CD are parallel straight lines. And let the square SN be constructed. Okay, we're constructing this square. And it's going to be equal to the parallelogram AH. This area and this area are going to be exactly the same. And the square NQ, this area right here, is going to be equal to the area in GK. And let them be placed so that MN is in a straight line with NO. So this is in a straight line like it was in the last proof. RN and NP are also in a straight line. Let the square SQ be completed. So this plus this plus this plus this whole area is SQ. And it's a square. Okay. It is then manifest from what was proved before that MR is a mean proportional between SN and NQ. Okay. MR, right here, that area is the mean proportional between SN and NQ. And it is equal to EL. So, this area and this area are exactly the same. And then MO is the side of the area AC. This and this are the same length. It is now to be proved that MO is the first bimedial straight line. Since AE is incommensurable with length with ED, since this length is not commensurable with this, while ED is commensurable with AB, okay, this length is commensurable with this. Therefore, AE is incommensurable with AB. This length is not commensurable with this. And that's by Euclid Book 10, proposition number 13. And since AG is commensurable with EG, okay, AG and EG are commensurable, AE is also commensurable with each of the straight lines AG and GE. This whole length right here is commensurable with AG and GE. But AE is incommensurable in length with AB. This is incommensurable with this. Therefore, this length is incommensurable with this, and this length is incommensurable with this. And that's by Euclid Book 10, proposition number 13. Therefore, AB and AG, AB and AG, and AB and GE are pairs of rational straight lines commensurable in square only, so that each of the rectangles AH and GK are medial. Okay. This rectangle is medial, and so is this. That's by Euclid Book 10, proposition number 21. Hence, each of the squares SN and NQ are medial. This and this, these two squares right here are medial. Therefore, MN and NO are also medial. So this line and this line are medial lines. And since AG, okay, AG right here, is commensurable in length with GE, since this is commensurable with this, AH is also commensurable with GK. This area is commensurable with this. That's by Euclid Book 6, proposition number 1, and Euclid Book 10, proposition number 2. That is, SN is commensurable with NQ. This is commensurable with that. That is the square on MN with the square on NO. Alright. Now you have to keep in mind that the square on MN here is MSPN. That's the square on MN. Okay? The square on NO is NRQO. That's this one right here. Okay. And since AE is incommensurable with length with ED, since this is incommensurable in length with this, while AE is commensurable in length with AG, while all of this is commensurable with this, and ED is commensurable with EF, this is commensurable with this, therefore AG is incommensurable with EF. This is not commensurable with this. That's by Euclid Book 10, proposition number 13. So that AH is incommensurable with EL. This area right here and this area right here, they're not commensurable. That is, SN is incommensurable with MR. Okay? These two areas are not commensurable. That is PN to NR. So, this line right here and this line right here are not commensurable. This is by Euclid Book 6, proposition number 1, and Euclid Book 10, proposition number 2. That is, MN is incommensurable in length with NO. This length is incommensurable with this length. But MN and NO were proved to be both medial and commensurable in square. Okay? These two lines are medial, and they're also commensurable in square. Therefore, MN and NO are medial straight lines commensurable in square only. I say next that they are also they also contain a rational rectangle. For since DE, well, what's DE? This is this right here. Is by hypothesis commensurable with each of the straight lines AB and EF. So this is commensurable with this and also with this. Okay. Therefore EF is also commensurable with EK. EF and EK are commensurable. This is by Euclid Book 10, proposition number 12. And since each of them is rational, EF is rational, EK is rational. Therefore, EL, that is MR, is rational. This area right here is the same area as MR, which is this area right here. These two areas are exactly the same. Therefore, this area is rational, so is that. MR is the rectangle MN and NO. How do we know this? Because the length of NO and the length of NR are exactly the same length. So, this rectangle is MN and NO. But if two medial straight lines commensurable in square only and containing a rational rectangle be added together, the whole is irrational and is called a first bimedial straight line. This is by Euclid Book 10, proposition number 37. Therefore, MO is a first bimedial straight line. This is a first bimedial straight line. Alright. I will tell you more in a future video. Stay tuned.